In lesson 8.6, we're going to solve rational expressions. And the first one's pretty basic. We know we can use cross multiplication. We can say 1 times 8 is 8, and 2 times 4 is 8. And sometimes, of course, we'd have variables, and we're solving for the variables. We are getting rid of the fractions. That's what we're actually doing. So to eliminate 2, we're going to multiply both sides by 2 because what we do to one side, we do to the other. And to eliminate the 8, we're actually multiplying both sides by 8. So let's do this problem again. So this is what we really did. We would say we would want to multiply both sides by 2. And we'd also have to multiply both sides by the 8 to eliminate the 8. So the 2 cancels, so we're left with 8. The 8 cancels, so on this side we're left with 8. And this is going to help us out as we progress with more difficult problems or problems with more steps. In order to determine what we need to multiply by to get our denominators to cancel, we're going to start with factoring. So we'll take out a 2, so we're left with x minus 5 on the right. So unfortunately, if we look at the left and we look at our factors on the right, we don't have anything in common. So thinking back to what I just showed you about cross multiplying, we're going to multiply the fraction on the left by 2 times x minus 2 times x minus 5 and do the same thing on the right. Now we can start canceling. So we can cancel out our x minus 2's, and on the right we can cancel out our 2's and our x minus 5's. So we're left with 2, x minus 5, and 7. So that's really 14 times x minus 5 equals 11 times x minus 2. So we're going to distribute 14x minus 70 equals 11x minus 22. And then we can subtract 11x from both sides. 3x minus 70 equals negative 22. Add 70, 3x equals 48. Divide both sides by 3, so x is equal to 16. And then we have to remember to put this value, 16, check it, put it back into the denominators to make sure that we didn't create extraneous solution. We don't want the denominator to be equal to 0 because then it would be undefined. We're going to apply the technique I just showed you to this problem. So we look at the denominators. We have x, 5, and x. So in order to eliminate the denominators, we're going to multiply every term by 5x. We have to multiply everything by the same thing. And then we're going to start canceling. So we can cancel out our x, then we can cancel out the 5, and here we can cancel out the x. So we're left with 5 times 15. I'm going to use parentheses. That's just a little cleaner. I'm going to use 5 times 15 plus 4x equals 35, which is 75 plus 4x equals 35. We can subtract 75 from both sides. So 4x equals negative 40, x equals negative 10. And if we substitute this back into our denominators, none of our denominators come out to 0. This next problem is a little bit different. We still have 3 fractions if I put a 1 underneath this one. And that just helps me to remember to include that when I'm multiplying. So I look at the denominators, and we can multiply everything. We have an x and an x plus 7. So we're going to multiply each one by x times x plus 7, x times x plus 7, and x times x plus 7. We're going to do our canceling. Nothing can cancel with this term. And then we can cancel out this x. So we're left with 12x equals x times x plus 7. And then we have this negative 12. So we end up with negative 12x minus 84. Okay, so I got a little bit sloppy here. So you couldn't really tell that I had crossed off this x because the blue line bled into the x. So we have our negative 12 times this x, and then the negative 12 times this 7. So just to make that clear. And then we're going to simplify it. So we end up with 12x equals x squared plus 7x minus our 12x minus 84. We want to move over our 12x to this side, and then we're going to combine our like terms. So we want this to be 0 equals, we have our x squared, we have negative 24x and a positive 7x. So that's going to give us negative 17x minus 84. And then we want to factor. And we need to find something that multiplies to negative 84, yet adds to negative 17. So that would be minus 21 and plus 4. Multiplies to negative 84 and adds to negative 17. Then we set each parenthesis equal to 0 using our zero product property, and we can find out that our answer is going to be x equals 21 or x equals negative 4. Two last things before we move on to our last problem. When I talked about the zero product property, we set each of these parentheses equal to 0, and we added 21 to both sides, and over on this one we subtracted 4 from both sides. Also, remember we put the 21 and the negative 4 back into our denominators to make sure that they work, and in this case both work. Okay, so we're starting off with this original problem here. I did two things to it already. First, I put a 1 beneath the 5, so we can see that we have 3 denominators. And then the x squared minus 1, we have the difference between squares, so I factored. Then I could determine what we needed to multiply each fraction by. So I'm going to begin canceling x minus 1 and x minus 1. We can't cancel anything with the 5, but we can cancel out everything over here. So now we end up with 7 times x plus 1 minus 5, and we knew I got that from the x squared minus 1, so I'm just gonna FOIL that or multiply that back to get our x squared minus 1 equals 6. And then we keep on going. We're going to distribute 7x plus 7 minus 5x squared plus 5, a negative and a negative, equals 6. We're going to combine our like terms and get a 0 on one side. And because our leading coefficient here, the x squared, is negative, I'm going to go ahead and move everything over to the right so that it becomes positive. So I subtracted, then here we added, put everything over on the right, combined the like terms, then I factored, used our zero product property, and found out that x equals negative 3/5 or x equals 2. But let's take a look, I want to remind you on how we factored the 5x squared minus 7x minus 6. So we multiply the first and the last term together and we get negative 30. We bring down the 5x squared. We bring down the minus 6. We find something that multiplies to negative 30 yet adds to negative 7. And that would be negative 10. And we're going to include the x and a plus 3x. Then we're going to use our factor by grouping. We factor out a 5x, we're left with x minus 2. We factor out a 3, we're left with x minus 2. Then we take our lookalikes, they become 1 parenthesis, and our leftovers, that becomes the second parenthesis. And you can see that that's what I got over here, 5x plus 3 and x minus 2. And then again, once we get our answer, make sure you put that back into the original problem's denominator to make sure we don't have extraneous solutions.